Hi guys, in this video I'm going to make an introduction to trigonometry. I assume most of you forgot what you learned about trigonometry in grade 10. So I thought making a quick revision will be beneficial to you because the information that I'm going to revise in this video, you will need them all throughout the chapter. So let's get started. Let me remind you what trigonometry is first. So trigonometry is a branch of math involving angles and sides in the right triangle, the relationship between angles and sides in the right triangle. So we have three most common trigonometric functions, which are sine, cosine, and tangent. So sine of theta is the ratio between opposite side and adjacent side. The cosine of theta is the ratio to adjacent to hypotenuse, and tangent theta is opposite over adjacent. So let's take a look at this example. We are given a right triangle here, and we have theta here. Opposite side is 4, adjacent side is 3, and hypotenuse is 4. So let's find the trigonometric functions, the values of each trigonometric function in that right triangle. So sine theta is opposite over hypotenuse. So opposite is 4, hypotenuse is 5. So it's 4 over 5. Cosine theta is adjacent over hypotenuse. Tangent theta, opposite over adjacent. So if you have difficulties in remembering these ratios, you can use this as a hack. So, ka, toa. What does that mean? So stands for sine is equal to opposite over hypotenuse. Ka stands for cosine equals adjacent over hypotenuse. And toa stands for tangent is equal to opposite over adjacent. It's a good way to remember that if you are confused with the ratios. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent equals opposite over hypotenuse. So ka, toa. So the second thing I'm going to remind you is signs of trigonometric functions in each quadrant. So as you know, x coordinate represents cosine axis, so x-axis represents cosine axis, y-axis represents sine axis. So that's the origin. And right side of origin, you have positive numbers, so your cosine is positive. Above origin, you have positive numbers, so your sine is also positive. As you know, tangent is equal to sine over cosine. So the ratio of sine and cosine, positive over positive, is positive. So tangent is also positive here. So let's move on to second quadrant. In the second quadrant, left side of the origin is negative, so cosine is negative. Above origin is positive, sine is positive, so your tangent will be positive over negative, which is negative. So let's continue with the third quadrant. In the third quadrant, left side of origin you have negative, so cosine is negative. Below origin, sine is negative, so tangent will be the ratio of negative over negative, which is positive. Last quadrant, quadrant 4. Right side of origin, positive, so cosine positive. Below origin, sine, which is negative. So tangent is the ratio, it is negative. You don't have to memorize these signs. If you know what cosine axis represents, what sine axis represents, you can find each sign easily. Let's move on with trigonometric ratios of spatial angles. There are many ways of finding trigonometric ratios of spatial angles. The first way is using spatial triangles. You learn these spatial triangles in grade 10 as well as in the first term in first chapter, I guess. So we have 30, 60, 90 spatial triangle and 45, 45, 90 spatial triangle. You know the relationship between them. So by using these relations, you can find sine, cosine, and tangent of each angle here. You can also find sine, cosine, and tangent of 45 here. That's the first way. So the other method is using unit circle. Unit circle is a circle whose radius is 1. You know there's 0 degree here. When we go a quarter circle, it's 90 degree. Go half circle, it's 180 degree. Do 3/4 circles, 3 pi over 2, 270 degree. Go once around, it is 360. When you go once around, it is 360, which is 2 pi radian. You need to know these angles at least. This is based on using ratios of spatial triangles into the coordinate plane. So you can use this, you can form these spatial triangles into the coordinate plane to find each value of each trigonometric function for each angle. What I want to talk about here is this. I like this one better. This is like a math hack. You are given a square root over 2. So above square root, you are given spatial angles in order from smallest to biggest, 0, 30, 45, 60, 90 degree. On the left of square root, you have sine and cosine over 2. So numbers inside square roots are arranged from 0 to 4 at first, and then in the second row, 4 to 0 from biggest to smallest. So let me show you how it works. So let's say you're gonna find sine 45. So here is 45, here is sine. So number under 45 and next to sine is 2. You're gonna find sine 45. Number under 45 is 2. Under square root, don't forget that square root, over here 2. So that's the value of sine 45. It's pretty easy. Let's say you want to find cosine 60. Under 60 and next to cosine, you have number 1. So cosine 60 is equal to 1. Under square root is the same as 1 over 2. So that's the value of cosine 60. What about tangent? You may say that there's no tangent written here. How can I find tangent? Tangent is not given, but you know that what tangent is sine over cosine. Tangent is sine over cosine. So let's say you want to find tangent 30. So you first need to find sine 30 and cosine 30 and divide them. What is sine 30? Sine 30 is 1 over 2 over cosine 30. 30 is here. 3, it's under square root over 2. Let's take their ratio. So 1 over 2 multiplied by 2 over root of 3. 2 will go. So 1 over square root of 3 is the value of tangent 30. So it's pretty simple. You may say that we already have our calculators. We are finding every value by using calculator. We don't need this stuff. You're right, but some calculator gives you decimal numbers. If you don't want to work with decimals, if you don't want to see the decimal results, you may use this. It's really a good way to remember values of basic trigonometric functions. So next thing I'm going to remind you is reference angle. So what's reference angle? Reference angle is an angle that's located between positive x-axis and the terminal side of the angle. So let's say that's the terminal side of the angle. So this is your reference angle in the first quadrant. What about the second quadrant? In the second quadrant, here is also reference angle. It's adjacent to x-axis. In the third quadrant, here is the reference angle. fourth quadrant. Here is the reference angle. So your reference angle is always adjacent to x-axis. Be sure that you are not taking these parts of the angles. You are going to take the angles that's located next to x-axis. For finding reference angle, let's say your reference angle is given as theta. How are you going to find your original angle? So let me write the formula for finding original angle for each quadrant. So in the first quadrant, your original angle is theta itself. In the second quadrant, your original angle is pi minus theta. Here is 0 degree. Here is 0 degree. Here is pi over 2. Here is pi. Here 3 pi over 2. And here 2 pi. So in the third quadrant, your original angle will be pi plus theta. Pi plus theta. Because you are adding 180, you are adding 180 to the reference angle. So in the last quadrant, you are subtracting off the reference angle from the whole circle. So 3 pi, which means 362 pi minus theta. That's the way of finding original angle in each quadrant if you are given the reference angle. So theta itself in the first quadrant, second quadrant, theta pi minus theta, third quadrant pi plus theta, last quadrant 2 pi minus theta. Next topic, converting angle measures. So if you are given degrees, you can convert it to radians, or you are given radians, you can convert it to degree easily. Let me show you how to do. So the formula here is given as degree multiplied by pi radians over 180 for degree to radian. For radian to degree, radians multiplied by 180 divided by pi radians. So let's solve an example. For example, 30 degree. You're going to convert it to radian. So this time you're going to multiply it by pi radian over 180. So let's simplify it. It's going to be pi divided by 6. Let's do the reverse. Let's say you are given a radian, say pi over 4, and you want to convert it to degree, so you multiply it by 180 divided by pi. So your goal is cancelling out pi's here, cancelling out angles. So cancel out pi's and simplify, you're going to get 45 degree. That's it. Let's move on. The last thing I'm going to remind you is finding values of trigonometric functions. So let's suppose that you are given one trigonometric function, sine of theta, which is 3 over 5 in quadrant. Which quadrant is that? Between 90 and 180. Here is 90, here 180. So which means our angle will be located in the second quadrant. In the second quadrant, draw your angle, form a right triangle. That's your angle. Form a right triangle. You are given sine as 3 over 5. What is sine? Sine is opposite over hypotenuse. So your opposite side is 3, hypotenuse is 5. You need to find the adjacent side. So you know opposite, you know hypotenuse, you don't know adjacent. You can find it easily by using Pythagorean theorem. So 5 squared equals 3 squared plus x squared. Or you can recognize the spatial triangle here, 3, 4, 5. If you know it by heart, you can use it. If you don't know, use the Pythagorean theorem. So it is here. Here it is 4. So now we can find the other trigonometric functions. We need cosine, which is equal to adjacent over hypotenuse. So adjacent side here is 4, but make sure that you are using the correct signs for each number. So for number 3, it is the vertical line. So the vertical line here is positive, so 3 is positive. So hypotenuse is always positive, but on the left of origin, you have negative numbers. It's in the negative direction. So it's not 4 actually, it is negative 4. You have to be careful about that. It is negative 4 because it's on the left. So your adjacent is negative 4 and your hypotenuse is 5. Here is what your cosine theta is. What about tangent theta? Let's find tangent theta. Tangent is opposite over adjacent. What is your opposite side? Your opposite side is positive 3. Your adjacent side is negative 4. So here is your tangent function. We are going to use the forming right triangles in the quadrant in coordinate plane very often, so you have to know this very well. So that's all I wanted to talk to you about before we start our actual topics in trigonometry.